Inside this advanced manufacturing complex, engineers assemble the next generation of ultra-high-speed magnetic levitation trains.
We need to verify the seam alignment right here before the welding begins.
The holographic data confirms it's within tolerance. Align the panel precisely with the markers.
Confirmed. Tolerance is within specifications.
Advanced robotics and precision engineering converge here to build the world's fastest magnetic levitation transportation system. Heavy hydraulic presses extrude heated aluminum billets to form the long structural beams of the maglev chassis.
Precision CNC milling machines cut and smooth aluminum beams to achieve accurate alignment for the maglev frame. Engineers use laser measurement systems to verify the straightness and dimensional accuracy of each aluminum beam. Finished aluminum structural beams are now prepared for transfer to the next stage of maglev chassis assembly. Heavy gantry cranes position aluminum beams into rotating jigs to begin the maglev underframe assembly.
Friction stir welding tools fuse aluminum beam joints to create a rigid structural backbone for the maglev chassis. Heavy rotating jigs reposition the aluminum underframe to allow robotic welding across the full structural floor grid. The completed aluminum underframe backbone is now ready for integration with the maglev body structure. Curved aluminum ribs anchor into the assembly jig, forming the initial backbone of the maglev nose structure.
Robotic welding systems join curved ribs and tubes to build the hollow maglev nose framework.
Engineering teams verify the blunt nose geometry to maintain stable aerodynamic performance. The hollow maglev nose skeleton is structurally complete and ready for integration with the vehicle body.
Massive gantry cranes position aluminum sidewall panels onto the chassis to begin forming the primary maglev body shell. Automated riveting systems secure aluminum panels to the chassis, creating a unified maglev structural frame.
Precision laser systems verify the alignment of the roof modules across the unfinished maglev body shell.
Right here, this connection point seems slightly off specification according to the diagnostic data. Let me check the alignment again. The oscillation dampening looks stable. Confirmed. All tolerances are within the green.
The unfinished aluminum body structure is now prepared for the installation of magnetic levitation hardware.
Heavy hydraulic platforms lift the primary electromagnetic modules into position beneath the structural aluminum maglev chassis.
Lower the module slowly, 5 millimeters.
Confirmed. Alignment is optimal. Lock it in place.
High-torque tools secure the electromagnetic levitation modules firmly to the aluminum undercarriage structure. High-capacity electrical connectors deliver electrical power to the copper coil electromagnetic levitation modules.
Reading steady at 10 millimeters.
Acknowledged. Proceed to the next module.这些线圈需要再检查一下。
好的，我立刻安排。
The levitation and guidance magnet system is now fully integrated across the structural maglev undercarriage frame.
Massive high-voltage electrical networks are integrated into the structural vehicle shell to supply power for the electromagnetic levitation systems.
We need to route this bundle according to the schematic here.
Yes, ensure it clears the aluminum rib by 5 millimeters.
Advanced liquid cooling systems circulate specialized coolant to regulate the thermal load of the high-power electromagnetic propulsion systems.
Thermal inspection systems verify the stability of the high-voltage distribution network powering the electromagnetic propulsion systems.
The installation of the electrical and thermal infrastructure establishes the core energy systems required for ultra-high-speed maglev operation. The aerodynamic nose structure begins taking shape as composite layers are bonded over the completed aluminum frame.
Bring it forward slowly.
Steady. Watch the edge clearance.
Panel is seated, preparing for securing.
Composite layers bond precisely to form the aerodynamic nose structure of the CRRC 600 km/h maglev prototype.
Slowly, slowly. Guide it down. Almost there. Keep it straight. Okay, engage the suction.
Controlled heat curing permanently bonds the composite aerodynamic shell to the structural aluminum frame. The structural skeleton is now encapsulated within a continuous aerodynamic composite surface, ready for the next stage of manufacturing. Precision steel support frames anchor the foundation of the maglev driver command center inside the nose structure. Fiber optic communication networks connect the electronic control systems that guide the high-speed maglev prototype.
The locking mechanism is engaged.
Confirmed. The alignment is perfect according to the diagram.
Torque is set on the lower bolts.
Okay, confirming against the schematic. Wiring looks secure.
Technicians verify high-speed data communication channels, linking the control modules throughout the maglev command center.
The Maglev Driver Command Center is now structurally integrated and prepared for the next exterior finishing phase.
Automated surface preparation ensures the composite skin is perfectly smooth before the application of industrial primer.
Advanced robotic spray systems apply a uniform layer of primer to protect the vehicle from high-speed friction.
Digital coating gauges confirm the primer thickness remains within strict engineering tolerances across the aerodynamic maglev nose surface. The completion of surface treatment provides the final protective layer necessary for the upcoming high-speed system validation.
The undercarriage scan is complete. Data looks stable.
Confirmed. We are cleared for the initial power-up sequence.
High-capacity power umbilicals supply the electrical energy required to initiate the static levitation validation process. Activation of the electromagnetic core distributes controlled current to the levitation modules beneath the maglev vehicle body. Engineers verify the precise 10 mm levitation gap required for stable, high-speed magnetic suspension.
The sensor reading on line 3 is unstable. Adjust the calibration matrix by 5 degrees.
Confirmed. Applying the adjustment now.
Successful static levitation confirms the readiness of the vehicle's magnetic suspension systems before high-speed track testing. The completion of the maglev prototype represents the pinnacle of modern high-speed rail engineering and structural manufacturing.
这里表面处理得很完机，检查一下这里的浮膜。
正在炒红，公差符合规格。
很好，最粗细粗确溜。
Final factory inspections confirm that the integrated magnetic suspension and control systems are ready for operational testing. From raw materials to magnetic flight, this machine now represents the future of ultra-high-speed ground transportation. NextGen Machine Works, building the impossible. Subscribe to join the future.